Hello everyone, in this video we are going to cover the next area of working capital management, and that is inventory. Now we all know what inventory is. If you come to the page number 37 of your lecture notes, we will be starting from here onward. The first 3 points will elaborate briefly what we will be covering in this area. Let's see what they are. Inventory includes raw material, work in progress, and finished goods that are considered as one of the business assets that are ready or will be ready for sale. We all know what inventory is. It includes raw materials, finished goods, and work in progress as well. We all also know that it is represented as a current asset and hence the part of working capital. Now there are three costs which needs to be managed, or which needs to be, you can say, look after for proper inventory management. These are purchasing costs, ordering costs, and holding costs. The objective of working capital management in this area, that is inventory management, is here to minimize the inventory costs, which can be achieved by setting inventory levels and via EOQ, or economic order quantity. Now this is best understood if I can put that in a chart. Firstly, we have inventory. Now inventory, the most important thing that we will be going through, or which we will be learning to manage over here, is the cost of inventory. And the cost is made up of three elements, that is purchasing cost, ordering cost, and holding cost. Now we know that there is inventory, and now we know there is cost. The next step is where we financial managers come into play, and that is management, that is inventory management. Now there are two ways through which we manage inventory. Not exactly ways, or you can say it's like two steps through which we manage inventory. First, we have got inventory levels. Then we have got EOQ, or economic order quantity. Now moving back to our notes, let's get an idea about what inventory level is, and then we will be moving towards the EOQ. These are the things through which we will be covering the inventory management. Now there are certain levels that need to be set in when managing inventory, so that all the risk associated with the inventory management, that is risk of stock out and the risk of wastage, or you can say the risk of inventory being wasted, such sort of risk can be managed or eliminated. What we do over here is that we set certain levels and respond accordingly. The best way of learning this area is through an example. Firstly, let's just go through what each level represents. We have got a reorder level, which determines the level at which new order should be placed. This is a bell ringing area where management gets a signal or an indication that we now need to place our next order of supplies. Then we have got a formula for it, that is maximum usage and maximum lead time. The next area is minimum level. Now if this provides an indication to management that inventories are reaching dangerously low level, which might give rise to stock out. This is the minimum level. Minimum level means that inventory can go into stock out at any time now, which can seriously halt the production process. The formula for this is reorder level less average in usage and average lead time. Then we have got maximum level. It provides an indication to management that we are overstocking the inventory. Our reserves are getting dangerously full, which means that now the stock will start to get wasted or dangerous. We are significantly increasing our holding costs by keeping too much stock. That inventory, the definition also stays the same. It provides indication to management that inventory is approaching a wasteful level. The formula for it is reorder level plus reorder quantity less minimum usage and minimum lead time. Then we have average inventory. The average inventory computation is basically used for determining the holding cost. However, it gives a very good idea about how much on average the inventory should be present in our premises to keep the operations, to keep the production process going smoothly. The formula for this is buffer safety inventory plus reorder quantity divided by 2. So I've included an example in for better understanding of this area. I have also drawn a diagram for the ease of understanding. Firstly, we are computing reorder level for this example. Now, before we go into the computation, let's have a look what's going on in this example. The following information relates to Henrico. As I've just told you, all our examples include the same company, Henrico. We've got the data given over here of its inventory usage areas, that is maximum usage per day, minimum usage per day. Then we got average usage per day, maximum lead time. Lead time involves time it takes for the inventory to reach our premises. Then we have got minimum lead time. Then we got a reorder quantity. And the requirements tells us to calculate reorder level, minimum level, maximum level, and average inventory. We are starting with the reorder level because most of the other levels require reorder level in their computation, so we need to first compute reorder level in order to compute other levels. The formula for reorder level is maximum usage multiplied by maximum lead time. Now the maximum usage over here is 400 units, that is the maximum usage per day is 400, and the maximum lead time is 10 days. We are using these two figures just for the indication, and this becomes 4000 units. Now what have we computed over here? We have computed this level over here, that is 4000 units. Now whenever our stock reaches around 4000 units, it's an indication to management that we now need to place our order. Then we have got minimum level. Now minimum level is reorder level less average usage multiply by average lead time. That's the formula for this. We have already computed our reorder level, which is 4000 units. Then we have our average usage. Our average usage, as for example, is 225 units per day, and our average lead time is 7. We are taking the average of 4 and 10 over here. That is 4 plus 10 and divided by 2, we get an average lead time. Computing all this, we have 2425 units. Now we have calculated the minimum level, which is 2425 units. I've drawn a silo over here for better understanding. If our inventory level reaches 2425 units, it provides another signal. This time the alarm is much louder because it means that we can get stock out of inventory of supplies at any moment now. Then we are computing maximum level. I'm using short form, that is reorder level plus reorder quantity. The formula is minimum usage multiplied by minimum lead time. Now, one thing I need to make it clear over here, in the exams, do not use the short form, whether it comes to ratios, whether it comes to inventory levels or anything. It's best if you mention the full form of the formula for ease of gaining the marks, because it makes it easier for the examiner to give you the marks. Okay, we have got the reorder level of 4000 units. Now we require reorder quantity as well. We have got a reorder quantity of 8000 units as per our example. Then, and we need to, in between there's a negative sign. Most students forget that when it comes to minimum level or maximum level, before the bracket there is a negative sign, so do take caution over here. Then we got 100 multiplied by 4. As per the formula, minimum usage is 100 and minimum lead time is 4 days, which gives us 11,600 units. We got a maximum level of 11,600. After this, whenever our inventory level reaches this at this quantity, it means that we have overstocked ourselves. It's better to avoid certain purchases now, so that we can reduce the inventory level to a certain or to an average inventory level, so that there is not much of a holding cost. Then we have average inventory. The formula for this is buffer or safety inventory, or minimum level. In this case we will be using minimum level, plus reorder quantity divided by 2. Putting the figures, we know what is our minimum level, that is 2425 units. Then we have got reorder quantity is 8000 units. Dividing this by 2 will give us 6425, which is the average inventory which should be present in our premises at all time, and it can also be used to compute holding cost. So that is it for the inventory levels. Moving on to our next area. That is the reorder quantity. Now most students, they have already covered that in their past papers or past exams. So let's just go through it over again. Reorder quantity is the order quantity at which the holding cost and the ordering cost are same, and the sum of these two is at minimum. Basically, reorder quantities tells the financial managers that this is the level which should be ordered whenever we need to place an order, so that this why we compute this quantity, because at this quantity all our costs are kept at minimum level possible. It's a mathematical formula for this. Now one thing that needs to be cleared over here is that EOQ level, at economic order quantity level, the holding cost and the ordering cost sum, where the holding cost and ordering cost figure will always be the same. This has been examined frequently, and most students fail to take this into account. We will be going through an example also in this regard, in which you will get a better understanding and clear picture about it. For now, you need to know that at EOQ level, the holding cost and ordering cost are the same, and the sum of these two figures is at minimum. The formula of EOQ is 2 COD over CH. CO tells us about cost of placing one order, CH is holding cost, and D is annual demand. Now there are certain assumptions for this formula. The purchase price per unit is constant, it does not fluctuate. No minimum inventory level. Then we got a demand and lead times are unchanged, which means the environment should be fixed. We do not expect in changing that EOQ work in changing circumstances. This is not how EOQ works. In a perfect world, this will give you a minimum order level which your business should place to keep their costs low. Now there's an example over here as well in relation to economic order quantity. Handico has a daily demand for ball bearings over 40 a day for each of the 250 working days, that is 50 weeks. The ball bearings are purchased from a local supplier for $2 each, that is our purchasing cost. The cost of placing one order is 64, that is our ordering cost. Regardless of the size of the order, the inventory holding cost expresses the percentage of inventory. Purchasing price is 25% per annum. What is the economic order quantity? Now let's solve that in our chart. Let's simply put, first thing we need to do over here is place the formula of EOQ. Over CH. Then we have got our first area, that is 2, which is consistent in every scenario. Then we need ordering cost. From the example, we can see the ordering cost is 64. Then we need the demand. Now annual demand is computed. If you can see the annual demand, it is 40. That is a day, and the assumption is 250 days a week. We are multiplying it with 250, and our answer of this becomes 10,000 units demanded. And then we need our holding cost. Now holding cost is 25% of 25% of, let's express the percentage of inventory, that is 25% per annum. That is the 25% of purchase price. So 25% of the purchase price we have is $2 each. And if you multiply and get a 25% figure out of this is 0.5 straight. Now computing all this will give you 1600 ball bearings, and that is your economic order quantity. That is the order which you need to be placed to keep the costs low, to keep the holding cost and ordering costs at the lowest level. Moving on to our next area, reorder level. Now uncertainties in demand and lead times to fulfill order means that inventory will be ordered once it reaches a reorder level, and that's probably is the reason why we computed all the levels, so that we can follow it to keep a track of the inventories, to keep the track on the cost, to manage the inventory. Then we have got, now there is a think of cost versus benefit when it comes to inventory management. So for most businesses, stock outs are not fatal. So if stock outs are worth taking, then for each possible reorder level and therefore each possible level of buffer inventory, we need to calculate the cost of holding buffer inventory or the cost of stock outs. The formula for this is cost of one stock out, expected number of stock outs per annum, and number of orders per annum. It's simple as that. You only need three figures. All will be given in an example, and you multiply it to get the decision, to get the figure upon which you can make the decision whether the stock out should be accepted or not. To decide if on the contrary, there is a thing called discount. To decide if discount is worthy on ordering large quantities, total cost will be minimized at the pre-discount EOQ level, so that discount is not worthwhile and the minimum order size is necessary to earn the discount. We need to compare all our three costs, that is the purchase cost, ordering cost, and holding cost, before taking the discount and after taking the discount, so that we can make a logical, rational decision whether we should order large quantities of goods or keep to our current economic order quantity when placing the order. Sometimes in most of the cases EOQ takes the lead, and it's always you can say that it's always the right option to go with the EOQ, but in certain circumstances the discount becomes so much great that it wipes out the EOQ and so gives start giving the benefit, in which case we will be ordering at the quantity upon which we will be getting the discount. So we need to compare the both the elements cost wise to make the right decision. This is again best understood if we can do an example with it. I have included an example about discounts as well. Now, before going into this area, let's read out what the question is telling us. Handicodes uses items of inventory as follows. We have been given some data over here. That is, purchase price is $96 per unit, annual demand is 4,000 units per year, ordering cost is $300, annual holding cost is 10% of purchase price, and then we've got economic order quantity, that is 500 units. Now here we are being offered a discount by a supplier if we place an order of 1000 units instead of 500 units. So let's see what we have got. Our economic order quantity, we have already been given our EOQ in this example. So let's move on straight with the computation. That is, if 500 units are ordered, we need to see three costs, that is purchase cost, ordering cost, and holding cost. Pay very close attention in this example because it has been examined previously. If it comes to inventory, this is the most technical area as it can get, so pay very close attention. Now we have got purchase cost is 96 per unit and annual demand is 4000 units, so our purchase cost becomes 384,000. Then we are computing ordering cost. Now the ordering cost over here is 3. We have been given ordering cost of 300, and we need it's obvious that we need to assemble this according to the 500 unit area. Our annual demand is 4000, and we are placing each order of 500 units. Computing these will give you an figure of 2400. Then we need to compute our holding cost. Holding cost, as the question tells us, is 10% of purchase price. Our purchase price is 96 multiplied by 10%, and we need to adjust this according to our demand, which is average of our ordering cost, average or our EOQ. It's average EOQ in short, and this will give you again 2400. Do you know why we have got the same figure of ordering cost and holding cost? Because 500 units is our economic order quantity, and we have just learned that at EOQ level our holding cost and ordering costs are the same, and the sum of these two, as I just told you, will be minimum. So right now we are adding all these three figures together, and the figure that comes over here is 388,800. Now this is the scenario of cost. This is the picture of the cost that we have at the EOQ level. Now let's see how we have been asked by the supplier that he will give us a discount of 8% if 1000 units are ordered. So second scenario is if 1000, pardon me, an extra 0, if 1000 units are ordered, again we need to compute purchasing cost, ordering cost, and holding cost, all of these costs. We have already computed the purchase cost of 4,000 units, that is 38,400 in the above figure. Now we need to just incorporate the effect of discount, which becomes, after it becomes, that is, we are being given the discount of 8%, which gives us that we need to take the figure of 92% of this total cost. It becomes 353280. Then we have our ordering cost. It is 300 as previously mentioned, multiplied by 4,000. Instead of 500 in the denominator, now we have got 1,000 units because the supplier is giving us the discount. If we ordered 1,000 units, we are taking that effect here, and this gives us 1,200. Our ordering cost becomes low. It was expected, since more units needs to be placed, are ordered. It means that our ordering cost, there will be less orders in a year. If you're getting the picture, for example, we were playing an order of 500 units, and now our ordering cost will be reduced to half because we are placing the double the quantity of orders which we were previously placing. So that's how our ordering costs will be reduced. Whenever the discount comes, it's obvious that the ordering cost will be reduced, since more units or more supplies will need to be uh, bought to gain the discount. Okay, we have got that is 96 of purchase price multiplied by 10% of 92% of this total figure. Take the effect of discount in the holding cost, multiplying it with 1,000 divided by 2, that is the average of order being placed, and this gives us the figure of 4416. Now computing this, we have got 358,896. As you can see from the example, our cost is reduced if we go with the discount, because ignoring the discount, our cost becomes 388, that is 388,800, and with a discount our cost becomes 358 or 358,896. So quite a bit of difference over here, around 24,000. The cost wise, around $24,000 difference is over here. So it's obvious that we will be going with that discount in this example. So the Henrico should order 1,000 units and obtain discount. Moving on to our next area in the notes of inventory, we have got inventory management just-in-time systems. It is a Japanese system. Basically, what happens over here is, why go with all the hustle of managing the inventory when you can just call it and get it? That's how just-in-time works. Introducing just-in-time might bring the following potential benefits: reducing in inventory holding costs, it's obvious, reducing manufacturing lead times, improve labor productivity, and reduction in scrap. What happens in just-in-time inventory management is that whenever business receives an order, it the business calls its supplier to bring the supplies for the products that needs to be dispatched. Now, instead of keeping the stocks of raw material in its own premises, it gets the contract from its supplier that it will supply our business the supplies whenever they receive a call from us, and this is the time in which this is the average time in which they will deliver the goods to us. So this is how the just-in-time inventory management works. Now, because of this, there are no holding costs. The business does not need to be concerned about wastage levels because we don't have a stock. We will not be reaching the maximum level. So in this way, whole of the hustle of managing inventory goes away. However, uh, it gives a lot of bargaining powers to the supplier, which means the supplier, we will always be calling our supplier in the time of need, which gives him the bargaining power to increase the prices whenever it wants. So this is not the highly uh, recommended thing when it comes to demand and supply. However, if everything is certain and it's in a this thing is in a country where there is not a lot of fluctuations in the prices, then this system could be followed. Just in time is not suitable in some cases. That is written over here. That is a restaurant, a hospital, etc. In a hospital, if you follow just in time, it's obvious that the patients won't be waiting for the emergency treatment for the hospital to get the medicines and medical supplies from its supplier. It has to be present in the premises because in this case stock outs or delay can be fatal. In restaurant businesses as well, you cannot exercise a just-in-time system. You cannot expect your vegetable supplier there to deliver the vegetable supplies after the customer places an order. It will frustrate the customer and it will simply leave the restaurant if he or she is getting if he or she getting his or her lunch in an hour delay time. So it is not neither practical nor rational to go with the just-in-time system in hospitals and restaurants, where stockouts could be fatal. As I just told you, increasing in prices by supplier under JIT can cause problems to the company. As I just told you, it gives a lot of bargaining power to the supplier. It can just call you and tell you whenever you place a call, it will just increase the price to get the benefit out of your need. So it's best to keep some level of inventory in your premises, or better to take a lot of time to increase the time that you take from your customer to deliver the goods, so that you can at least compare the suppliers from which to obtain the supplies. So that's it for the inventory management. That's the second chapter of working capital area. Thanks for watching.